So can anybody tell me the exact meaning of a fluid dynamics? What do you mean by fluid dynamics? Or else tell me what is the difference between fluid kinematics and fluid dynamics? Be quick.
Ma'am, in fluid kinematics, we doesn't consider the force which is causing the flow of fluid. In dynamics, we consider the force, ma'am.
We are going to consider the forces. Okay. Uh, like how many types of forces are you're going to consider in a fluid flow? How many types of forces are there?
Four forces, ma'am. Five, ma'am.
Which are those?
Gravity force, pressure force, viscous force, ma'am, and force due to turbulence and force due to compressibility, sir.
Okay. So what do you mean by Reynolds equation of motion? Can anybody tell me?
Compress if compressibility force is negligible, ma'am.
Okay. Then what do you mean by Navier-Stokes equation?
Viscosity force and compressibility force are both are negligible, ma'am.
Viscosity.
Viscous force, ma'am.
Any other answer? Actually, in this case, the turbulent force is neglected in case of a Navier-Stokes equation. And what about Euler's equation? Which forces are neglected in Euler's equation?
Viscosity force, ma'am, turbulence force, and compressibility force, ma'am.
Okay, if these three forces are not taken into consideration, then the equation is called as Euler's equation of motion. Okay, so these are the different forces. So if you go on neglecting each forces, then the particular equation is named as a Reynolds equation, Navier-Stokes equation, and Euler's equation of motion. In Euler's equation of motion, only the gravity force and the pressure force is taken into consideration. So this was the derivation. From this Euler's equation of motion, again we are going to derive the Bernoulli's equation. So the Bernoulli's equation is P by rho g plus V square by 2g plus Z is equal to constant, where P by rho g is nothing but it is the pressure energy or a pressure head. V square by 2g is kinetic energy or a kinetic head, and Z is nothing but it is the potential energy or potential head. So why repeatedly I am using this term pressure head, kinetic head, potential head? Why? Because in some of the problems, this ratio is directly given, like the pressure head is equal to this much. So if what do you mean by pressure head? It is nothing but it is the ratio of P by rho g. So you should come to know that pressure head is nothing but it is P by rho g. Okay. So from now onwards, we are going to use the word head. Okay. So in civil engineering, especially in irrigation engineering, head is nothing but it is termed as a height of water. Okay. So since the fluid mechanics is generally used in irrigation systems, so that's why I always give the example of irrigation systems. So if this is the dam, then the fluid which is available, okay, so the indication, the level of the fluid is indicated by this symbol. So from now onwards, you are going to learn different terms in civil engineering. So this is the level of the fluid. So the height of a fluid at the upstream side, so this is called as a upstream and this is the downstream, where the water is stored here and it is diverted to the downstream. So here the height of water or height of any liquid which is available. So this height we are going to call it by another name which is called as a head. Okay, head is nothing but it is height. So how we are going to measure the height? How we are going to measure the height? Can anybody tell me? How we are going to measure the height? My voice is audible to you all? Hello? Hello?
Yes, ma'am.
So how we are going to measure the height? Suppose there is any building, okay? So how we are going to measure the height of a building? What is the unit?
Meter, ma'am.
So meter or a centimeter or a millimeter. Okay. So these are the different units which we are going to use. What is the height of the dam? It will be very large. Okay. You can't measure the height of a dam, height of a building in terms of a millimeter or a centimeter. In spite of that, we are going to identify the height of any large structure in terms of a meters. Okay. So now, so pressure head is nothing but it is height. Pressure height, kinetic height and potential height. So now there are some assumptions are there. Assumptions of a Bernoulli's equation. Please mark it as an important one. Because every year in the examination they are going to ask you to derive the Bernoulli's equation and you have to write the assumptions. The first assumption is that the fluid is ideal. That is, viscosity should be 0. So this particular equation, P by rho g plus V square by 2g plus Z is equal to constant, this equation holds good when the fluid is ideal. That is, the viscosity is completely 0. Second thing, the fluid is steady. So when you say that the fluid is in steady condition, when dou v by dou t, that is velocity with respect to time is equal to 0. Okay. So if this condition satisfies, then we are going to call it as a steady flow. Okay. So the Bernoulli's equation holds good when the fluid is in steady condition. That is dou v by dou t is equal to 0. The third assumption is that the flow is incompressible. When you say the flow is incompressible, when the density is equal to constant. Okay. So when you say the fluid is incompressible, when the density is equal to constant. If the density is equal to 0, then we say that it is a compressible fluid. Okay. So this is incompressible. And the last assumption is that the flow is irrotational. So these are the 4 assumptions of Bernoulli's equation. First is viscosity should be 0. The flow is in steady condition. Flow should be incompressible and flow is irrotational. If this 4 conditions satisfies, then the Bernoulli's equation holds good. So this is regarding Euler's equation and Bernoulli's equation and its assumptions. So my dear students, is there any doubts in this? Is there any doubts? Is there any doubts? Please reply me.
No, ma'am.
What about others?
Ma'am,
Those who
slide
are
is not
present?
visible, ma'am.
Yes.
Slide is not
Slide
visible,
is
ma'am.
not
Yes, ma'am.
visible.
Slide is not visible.
Now it is visible.
Yes, ma'am.
Yes, ma'am.
Okay, those who are present, please raise your hands. Okay. Now we are going to solve few problems based on this concept. So take this problem. Water is flowing through a pipe of a 5 centimeter diameter. Water is flowing through a pipe of 5 centimeter diameter under a pressure of 29.43 Newton per centimeter square. And with a mean velocity of 2 meter per second. Find the total head or total energy per unit weight of the water at a cross section which is 5 meter above the datum line. Have you taken the problem? Have you taken the problem?
Yes, ma'am.
So there is a pipe. So what is the diameter of the pipe?
Meter, ma'am.
What is the diameter of the pipe?
Centimeter.
5 centimeter. So diameter of the pipe is equal to 5 centimeter. Okay. Apart from that, what are the other things they have given? They have given the velocity. So what is the velocity of which liquid is flowing here? Water is flowing. That is very much important. Okay. So you need to check which type of a liquid is flowing. The diameter of the pipe is 5 centimeter. Velocity they have given it as a 2.0 meter per second. That is 2 meter per second. Apart from that, they have given the pressure. Okay. So there is a large difference between pressure and a pressure head. So here they have given only pressure. Pressure head is P by rho G, where pressure is only P. Okay. So the pressure is 29.43 Newton per centimeter square. Okay. Apart from that, the pipe is at a 5 meter above from the datum line. Okay. So what do you mean by a datum? What do you mean by datum? Any idea? What do you
Reference
mean by
line,
it?
madam.
It is a
It is the
reference.
line that we considered.
Okay, it is a reference line. So there is a reference. So this is the diameter of the pipe. Okay. So if you consider this as a datum, so the height of the pipe from the datum is how much? It is 5 meter. Okay. So generally we are going to take the central axis. Okay. So the central axis of the pipe here. So from this center axis, the height of the pipe is how much? It is 5 meter above from the datum. So this line is taken as a datum. Okay. So now these are the given things. From this, identify the head. What do you mean by total head? Total head is nothing but it is P by rho G, sum of pressure head, kinetic head or a velocity head, and datum head, which is equal to constant. Okay. So now, so these all units, so some of the units are in terms of a meter and some are in terms of a centimeter. Okay. So it's better you keep all the units in terms of a meter itself. So diameter of the pipe is 5 centimeter. So in terms of a meter, it will be equivalent to how much?
0.5.
0.5 meter. Okay, this will be meter per second as usual. And what about the pressure? What about pressure? What about pressure?
29.43 into 10 raised to 4 Newton per meter square.
It is 29.43 into 10 raised to 4 Newton per meter square. Why? Because centimeter is nothing but it is 10 raised to 2. Okay. So it is in denominator. So when it comes to the numerator, it will be here centimeter square is there. So therefore it will be 10 raised to 4 Newton per meter square. Okay. So now how you are going to identify the pressure head? You need to identify the pressure head. You need to identify the velocity head, and datum head already they have given it is 5 meter. Okay. So now let us identify one by one. So let me consider first pressure head, that is P by rho G. Okay. So what is the pressure? Pressure is 29.43 into 10 raised to 4 whole divided by which type of a liquid is flowing here? It is water. So therefore, what is the density of water? It is 1000 into acceleration due to gravity is 9.81. Okay. So calculate this and tell me the answer. Next is velocity head, v square by 2g. Okay. Velocity is how much? 2. So 2 square whole divided by 2 into 9.81. So datum head is equal to 5 meter. Okay. So after that you need to tell me the total head. So total head is P by rho G plus V square by 2G plus Z. So what is the value of a pressure head? So 29.43 divided by 9.81. Tell me what is the
30,
answer.
ma'am.
30.
It is equal to 30 meter. Okay, next, what about this? Text your answers.
0.204, ma'am.
0.204. What is the unit?
Meter.
It is 0.204 meter. Hope all of you are getting the same answer, and this is 5 meter. So go on adding this. 30 plus 0.204 plus 5. So this will be 30 plus 5, 35.204.
35.204.
What is the unit?
Meter.
It is nothing but height. That is in terms of a meter. Okay. So this was the first problem. Understood how to solve these kind of a problems?
Yes, ma'am.
Okay, fine. So now let us solve another problem. Okay, take this. Water is flowing through a pipe. Water is flowing through a pipe having diameter having diameter 300 mm and 200 mm at the bottom and upper end respectively. The intensity of pressure at the bottom end is 24.525 Newton per centimeter square, and the pressure at the upper end is 9.81 Newton per centimeter square. Full point. Determine the difference in datum head if the rate of flow through the pipe is 40 liter per second. Liter per second. Okay, so this is the problem. Please take the diagram. So this is the problem. Okay. Have you taken the diagram? Please reply me.
Yes, ma'am.
Yes, ma'am.
So this is the given things of the particular problem. So here the diameter is equivalent to 200 mm. Okay. So this is the first section and this is the second section of the pipe. In the previous problem, the diameter of the pipe is constant both at the inlet and outlet. But here in this particular case, the diameter of the pipe is not constant. Here D1 is 300 mm, whereas D2 is 200 mm. Even the pressure P1 is 24.525 Newton per centimeter square and P2 is 9.81 Newton per centimeter square. Okay, because as the diameter changes, as the diameter of the pipe changes, all the things like velocity, pressure, so these things are going to change. Okay, so here as the diameter changes, the pressure and the velocity is also going to change. If the diameter is constant both at the inlet and outlet, then it is not going to affect the velocity and the pressure. So here two velocities, two pressure head they have given, pressure they have given. One is 24.525 and 9.81 Newton per centimeter square. So first thing you need to write all the given things, and here they have not given the datum head. Okay, so this is the datum. Z1 is nothing but it is the height of the first section from the datum, and Z2 is nothing but it is the datum head at the section 2 from the datum. So now please note down the given. So D1 is 300 mm. So convert all the units in terms of a meter. D2 is 200 mm. Simultaneously, P1 is 24.525 Newton per centimeter square it is. So convert it in terms of a meter, Newton per meter square. And simultaneously P2 is 9.81 Newton per centimeter square. So whenever you are going to solve the problem, make sure that you are going to write the given first, then convert the units. So you need to identify in this particular problem, you need to identify the difference in the datum head. Okay, Z2 minus Z1 because Z2 is greater than Z1. So you need to identify this difference. It is minus. Okay. So now tell me the value of a D1.
0.3, ma'am.
So it is 0.3 meter. Simultaneously, this is 0.2. This is 24.525 into 10 raised to 4. And this is 9.81 into 10 raised to 4. Okay. In which equation the term Z1 and Z2 are going to come? So P by rho G plus V square by 2G plus Z. So this equation is for only one section. So if you take two sections, so here we have taken two sections, then the equation will be P1 by rho G, V1 square by 2G plus Z1, which is equal to P2 by rho G plus V2 square by 2G plus Z2. Okay. So this is the equation of a Bernoulli's for two sections. Now here we know what is the value of a P and we don't know what is the value of a Z1 simultaneously in both the cases. So here two unknowns are there. So here two unknowns are there. So first you need to identify the velocity. Okay. So how are you going to identify the velocity? Can anybody tell me? How are you going to identify the velocity?
By A1 V1 equal to A2 V2, ma'am.
Which is that equation?
Direct flow equation, ma'am.
Huh? Which is that equation? You said that A1 V1 is equal to A2 V2. Okay. This equation is called as which equation? There should be certain name, right? We have kept the equation as a Bernoulli's. And what about this?
Continuity.
It is continuity equation. Okay. So now from this equation, you need to identify V1 and V2. So here in this particular equation, A1 V1 is nothing but it is the rate of flow. Okay. So rate of flow Q is equal to A1 V1 or it is also equal to A2 V2. So here again V1 and V2 are unknown. So take any one equation, that is Q is equal to A1 V1 because the rate of flow already they have given in the problem. So the rate of flow, that is Q is equal to 40 liters per second. Okay. So 40 liters per second is converted into meter cube per second because the discharge is meter cube per second, that is 40 divided by 1000. So this will be equal to 0.04 meter cube per second. Okay. So now they have given the value of a Q, that is 0.04. What is the area? It is a pipe, right? So the diameter of the pipe they have given. So therefore area will be pi by 4 into D1 square, that is 0.3 the square into V1. Okay. So 0.04 whole divided by pi by 4 into 0.3 square will give you the value of a V1. So now tell me what is the value of a V1? Please text your answers. Answer for V1 is equal to how much?
0.565, ma'am.
Text your answers. Suraj, what is the answer for V1? Suraj, are you there?
0.565, ma'am.
0.565. Okay. Now, how you are going to identify the value of a V2? Same, you can take Q is equal to A2 into V2. Okay, that is Q divided by A2 is equal to V2. What is the value of a Q? It is 0.04. A2 is pi by 4 into D2 square. That is 0.2 the whole square will give you the value of a V2. Mega, your answer is correct for V1. Calculate it for a V2 and tell me the answer.
Point 273, ma'am.
1.273. Okay. So how we are going to measure the velocity? Unit for velocity is meter per second. Okay. So now you got the value of a V1 and V2. Go on equating the value here. So P1 is how much? It is 24.525 into 10 raised to 4 whole divided by, so which liquid is flowing? Water. 1000 into 9.81 plus what is V1? 0.565 V1 square by 2G. So 2 into 9.81 plus Z1, I don't know. Simultaneously, what is P2? That is 9.81 into 10 raised to 4 whole divided by 1000 into 9.81 plus what is V2? It is V2 is how much? It is 1.273 the whole square. V2 square divided by 2 into 9.81 plus Z2. So what is the value of this? 2.525 into 10 raised to 4 whole divided by 1000 into 9.81. Tell me value of this. It is equal to 25. Okay. Next. What about this?
Zero point 0.016, ma'am.
0.016.
016.
0.016. Any other answers? Any other answers? 0.565 the whole square divided by 2 into 9.81.
Point 32.
It is equal to 0.32. 32. So somebody has got 0.016. So please make a correction. The answer is 0.32 plus a Z1. Simultaneously tell me the answer for this. What is the answer for this?
10.
How much?
10. 10.
Okay. Next. What about this? 1.73 the whole square divided by 2 into 9.81.
Zero point zero eight three one.
0.083. Any other answers? Please text me. Plus Z2.
1.623.
Final answer?
No one. That 0.083 is wrong. 1.623.
This one.
Yes, ma'am.
It is equal to how much? 1.623.
623.
Okay. Then what is the difference? Z2 minus Z1 is equal to how much? Add this.
Ma'am, that is 0.5665 whole square divided by 2 into 9.81. We getting that 0.0163.
Which one? This one?
Yes, ma'am.
That zero that we get when we square only 0.565. Squaring of that is 0.22, ma'am.
Check it once. 0.565 into 0.565.
That square only we get that 0.32, ma'am.
0.565. So divided by is this the answer? Is the screen visible?
0.62.
Yes, ma'am.
It is 0.0162.
In
0.0.
this also, ma'am, same that one, ma'am.
How much?
Here also, ma'am.
0.08.
0.0825.
0.0825.
0825.
Now tell me the difference of Z2 minus Z1. Difference of Z2 minus Z1.
Fourteen point 9342.
14.9342. What is the unit? What is the Z?
Meter.
Z is datum head. Okay, so therefore it is in terms of a meter. Okay, understood? Is there any doubts in this?
No, ma'am.
Okay, fine. Now let us solve another problem. So you note down the given things directly. So here in this case, please take the diagram, because whenever you are going to solve the problem, diagrams are very important. So this is the datum head. Sorry, datum line it is. And the diameter of the pipe. So this is the first section and this is the second section. So diameter here is D1, which is equal to 600 mm. Simultaneously, the value of a P1, they have given it as a 19.62 Newton per centimeter square. Simultaneously, this is the second diameter, which is equal to 300 mm. So in this particular problem, the length of the pipe is 100 meter. So directly they have not given the value of a Z1 and Z2. So the pipe is having a slope of 1 in 30. Okay, so these are the given things. So calculate and tell me the value of it. So here D1 is there, P1, D2. So P2 I don't know, P2 you have to calculate. Simultaneously, Z1 is also unknown. Calculate and tell me the results. First write all the given. So D1, which is equal to 600 mm. So it is in mm. In terms of a meter, it will be equal to 0.6 meter. Simultaneously, D2 is equal to how much? 0.3 meter. Then P1 is equal to 19.62 into 10 raised to 4 Newton per meter square. So this is Z2. So Z2 is coinciding with the datum. So therefore Z2 is equal to 0. And Z1 is 1 in 30 multiplied by length. So the length is 100 meter divided by 30. That is 10 divided by 3, which is equal to how much?
3.33.
3.33. meter. Okay. So now which type of a liquid is flowing here? It is a water again. So there are two sections. Write the Bernoulli's equation for two sections. That is P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, so here again the velocity is unknown. So here the value of a Q they have given here as a 50 liters per second. So Q is equal to 50 liters. So therefore, in terms of a meter cube per second, it is 50 divided by 1000, which is equal to 5 divided by 100. It is equivalent to how much?
0.05.
0.05 meter cube per second. Okay. So now applying the continuity equation, that is Q is equal to A1 V1. So tell me the value of a V1 here. V1 is equal to Q divided by A1. So here A1 will be pi by 4 into 0.6 the whole square. Simultaneously, A2 is nothing but it is pi by 4 into 0.3 the whole square. So tell me the value of A1 and A2. A1 is equal to how much?
0.28.
0.28. What is the unit? Meter square. What about A2?
Zero point zero seven zero.
0.070. Is the answer correct? All of you are getting the same answer?
Yes, ma'am.
Okay, then calculate V1. 0.05 divided by 0.28.
0.178.
How much it will be?
0.178.
What is the value of the unit of antigen?
178.
0.178 meter per second. Simultaneously calculate V2. Q is equal to A2 V2. So therefore V2 is nothing but Q divided by A2. That is 0.05 divided by 0.070.
0.7082, ma'am.
0.70
708.
meter per second. Now go on equating the values here. Equate the value of a P1, that is 19.62 into 10 raised to 4 divided by 1000 into 9.81 plus V1 square. V1 is 0.178 the whole square divided by 2 into 9.81. What about Z1? Z1 is equal to how much? 1 divided by 30. So that is
Then V2 to 0.71.
V2 is 0.711.
7 1 1
1 4. 1 4.
1 4.
7 1 4. Okay. Z2 is 3.33 is equal to P2, I don't know, divided by rho G. Rho value is 1000 into 9.81 plus V2 square is 0.714 the whole square divided by 2 into 9.81, and Z2 is 0 because it is coinciding with the datum. So now tell me the value of a P2. Calculate and tell me the value for P2.
into 10⁴.
20. Text me your answer. Text your answers. (22.86 into 10⁴). Any other answers? Any other answers? Text me your answers. Rohini Patil, are you there? Rohini, Sonia, Meher, Parvati Patil.
Yes, ma'am.
Text your answers. You people won't interact in the class. Apart from that, Rakshita Nayak, Vaishnavi, Darshan, Uzma. Calculate and tell me the answers. The other answer is 22.863 into 10⁴. What is the unit for this? What is the unit?
Newton per meter.
Why it is not meter? Why it is not meter? Meter per second. This is wrong. Usma, it is the unit of velocity. I am asking you, what is the unit for pressure? Somebody said Newton per meter.
Newton per meter.
Mega, right? Yourself mega, right?
Yes, ma'am.
Why not it is in terms of a meter? Previously we have calculated in terms of a meter, right?
Yes, ma'am.
Yes. Why you are measuring the value for P2 in terms of a Newton per meter square? Why not in terms of a meter? Tell me the reason. Just reply me. Darshan. Darshan Kalbhavi. Vaishnavi. You all are there?
Yes, ma'am.
Rakshita Nayak. Yes, Vaishnavi, tell me why you are not going to measure the value for P2 in terms of a meter? This answer is correct. P2 is 22.86 into 10 raised to 4. There are two units, meter and Newton per meter square. Which one is correct? Tell me. Which unit is correct? Either you have to take meter or you have to take
I
Newton per
choose it.
meter square. Yes?
Newton
Yes,
per meter
Vaishnav.
square, ma'am.
Why we have to take Newton per meter square? Why not meter? Tell me the reason. You said you are going to measure the pressure in terms of a
Because
Newton per meter square. Yes. Yes, Megha, tell me.
Ma'am, pressure is
because
measured
even
in pascals, ma'am.
No. I'm asking, in previous problems, you measured the pressure in terms of a meter. Now you are telling it should be in Newton per meter square. Which unit I have to consider? Because if you solve the problem and even the result is also correct, if you write a wrong unit, then everything will be wrong. You'll get 0
As
marks for this. Yes?
ma'am, as P1 is in Newton per meter square, ma'am, we have to take all the units in same units, ma'am. Like we have to take all the, like if P1 is also in Newton per meter square, we have to take P2 in same unit, ma'am.
That is not the reason. That is not the reason. The reason is P1 by rho g is what? P1 by rho g is what? What is the ratio of P1 by rho g or P by rho g?
Pressure head, ma'am.
Pressure head. What is that head? What is head?
That is distance, ma'am.
Or a height?
Yes, ma'am.
Okay, I'm not going to call it as a height. I'm going to call it as a head. Okay, this ratio is called as what? It is pressure head. Okay, so therefore you are going to measure in terms of a meter. So here, is there any ratio? Is there any ratio here? It is only pressure, not pressure head. It is only pressure. Pressure is measured in terms of a Newton per meter square or a Newton per centimeter square. Pressure head is measured in terms of a meter. That is the difference. Okay. So in the next problem, suppose if I take the ratio P by rho g, don't write the unit in terms of a Newton per meter square. Pressure is different. Pressure head is different. Okay. So this ratio is in terms of a meter. But only the P value is in terms of a Newton per meter square. Understood the difference? Now tell me which unit you are going to take.
Newton per meter square.
Newton per meter square.
Newton per meter square. Why? Because we are going to identify only pressure, not pressure head. Okay, understood? Is there any doubts in this?
No, ma'am.
What about others? Chaitranjali, Shilpa, Bhagyashri,
No, ma'am.
Raju. Is there any doubts in this?
No, ma'am.
No, ma'am.
Okay, fine. So in the tomorrow's class, I mean to say next class, I will be covering Bernoulli's equation for real fluids. So please solve the unsolved numerical problems from the exercise. And if you're having any doubts, you can contact me. So this is all for today. Let us meet in the